So good morning, good afternoon, and good evening, everyone from all parts of the world. It's exactly 6 p.m. Kenyan time, and welcome to our second event of the tinyML Kenya Meetup Group. So in this talk, Jan Jongboom, the CTO and co-founder of Edge Impulse, will talk about making Africa smarter with embedded ML. Next slide. So this talk wouldn't have been possible without the support of our sponsors and strategic partners. So a big thanks goes to Aeon Devices, Deeplight, Edge Impulse, EMSA, Greenwaves, Gravity Inc., Latent AI, HOTG, ImageMob, Maxim Integrated, which is now part of Analog Devices, Quixo, Qualcomm, Reality AI, Seed, SenseML, SciSense, and Sentient. Next slide. So I'm also pleased to remind you of the tinyML Asia, which will be happening between November 2nd to 5th this year. So if you haven't registered, kindly register using this link, or you can scan this QR code to attend. This event is free courtesy of our sponsors and strategic partners. And if you will want to be a sponsor, kindly reach out to sponsors at tinyml.org for more sponsorship opportunities. Next slide. So in collaboration with Hackster.io, the tinyML Foundation partnered for the tinyML Vision Challenge, whose winners were just announced last week on October 5th. And the winners were tinyML Aerial Forest Fire Detection, WorkSafe Computer Vision-based multi-parameter monitor, and a tiny SIWA, a low-power SIWA fault detection system. If you would like to learn more about the winners or the submissions that were submitted, kindly visit the competition's landing page on Hackster. Next slide. So my name is Clinton Odor, and I'm a co-organizer at tinyML Kenya, and I'll be moderating this session. Another committee member for the tinyML Kenya group is Joseph Shitote, who is a research assistant at the iLab Africa lab. So next slide. So our next tinyML talk will be on 19th October, which will be on Tuesday, and it will be about tinyML for conservation. If you want to submit any talks for the tinyML talks, kindly contact tinyML. Can you contact talks at tinyml.org for more information? So it's my pleasure to introduce to you our today's speaker, Jan Jongboom, who is the current co-founder and CTO at Edge Impulse, which is the leading development platform for embedded machine learning. So Jan is an embedded engineer and machine learning advocate who is always looking for ways to gather more intelligence from the real world. So the floor is yours, Jan.
Right. Thanks so much, Clinton, and also thanks, Joseph. He's not presenting today, but I know he's here in spirit, for inviting me. And I understand it might look weird. You figured, hey, we're at tinyML Kenya. What is this white Western European guy doing here? So in the next 30 minutes, I'd like to guide you towards kind of the experience that I have in building IoT systems, how machine learning came to play in that, and a really, really big role that East Africa played in that. And through that, I hope to share some of the war stories that I encountered trying to do something in East Africa. Hope to inspire everyone who's on here to actually start thinking about designing things for Africa, and also start thinking about kind of the challenges that are specific to society in that part of the world, and what we can do to make a positive influence. And man, I love this photo. This is made 4 years ago, during my first visit to Data Science Africa. So around at the end of 2016, Damon Sivin, he's a South African who was working at ARM, the same company that I was working at that point, got involved with Data Science Africa. I'd say it's a summer school, basically, for incredibly smart people in East Africa. At least when they started, they do something in Nigeria now as well. Where for about 2 weeks, students, master, PhD students get kind of thrown into the deep end with amazing lectures of people on site, actually fly in to the university and learn everything that there is to know about data science and how to get kind of the most stuff out of data. And so Damon approached me with this idea, okay, well, we see kind of as the lecturers in the summer school, we're still treating kind of data as something that is given, right? So we're training data scientists to look at the data that is in front of them and then draw conclusions from that. But there's one thing that you're kind of ignoring at that point, and that is that the data, that the data scientists can actually look at, needs to be caught somewhere, needs to be collected somewhere, needs to be cleaned up, right? The work of a data scientist, especially if you think about kind of cloud systems where you always work with digital data, often works already on relatively clean streams of data. But by far the most interesting part, at least for me, is when we actually start giving eyes and ears to stuff in the real world. And it's not as clean cut as just downloading a data set from Kaggle and doing some data science on it, but rather actually thinking about your data acquisition strategy. Like, what do I want to measure? What is the problem in society, or the problem that I encounter in my daily life? What is that problem? How can I kind of solve that or approach that? And then how do I actually go and actually gather that data? So Damon and I started kind of, together with Shira and Dina and the other organizers at DSA, started thinking about, okay, how can we broaden the horizon of data scientists in our world? And how can we actually add a little bit of this data acquisition step to the Data Science Africa program? So I joined. I'm not an ML engineer at all. I have a background in embedded systems. And for me, and I figured, okay, well, I'm just going to do kind of a workshop on, what IoT is and how you can gather some data from the real world. And that's kind of it, right? That's the bread and butter of IoT developers. The fun part for me at that point is that what I've learned probably more during the trip than all of the students learned from me while there. Because for me, this was the first time that I was working together as kind of the embedded person in a group with machine learning experts and data scientists. And they've shown me that there's a lot more value in the data that our IoT device can collect, right? The very first IoT device that people built, right, at least for me, is, I take a MCU, I take a radio, and then I have a sensor, temperature sensor or something, and every 10 minutes I send some data over. Going into the field in Tanzania, talking with people that think about this stuff much more, like Shira, for example, actually started realizing that, wait, if we don't treat data from our sensors as raw data, but rather actually do some intelligence over it, we can draw super interesting conclusions from the real world. And pairing that with, and that's kind of where the tinyML part comes in, pairing that actually with technology that lets us run those machine learning models directly on the sensor itself enables incredibly powerful things. Right? Because then now the sensor is actually aware of what's happening all around it and can start drawing conclusions from that. So that is an insanely powerful combination. And for me, that really opened my eyes. So Tanzania was the first time. I went back the year after to Nyeri at Dekut University in Kenya. And then in 2019, actually to Addis Ababa in Ethiopia. And unfortunately, last year we were supposed to go to Uganda, but COVID happened. But the thing that we did every year was, let's actually do something directly in the field. Let's tackle the problem that the universities or that the students or the lecturers see, and let's see what we can actually do with a combination of embedded systems and machine learning to kind of treat that. So long introduction, but that's the thing where the real interesting part comes from. This is actually a photo of Jared. I think he's one of Shira's students. And this was in between the first and the second year of DSA that I participated in. And this was not his life, not his full life. But it was actually to do, I think on the water level inspections, they created their own sensor, they actually put it onto a pole. And man, how much more fun is this part? And actually building a model based on the data that you actually collect yourself, rather than just downloading something from Kaggle and then trying to hit a benchmark, right? playing with models, really fun, but everything starts with data, and especially if you want to tackle novel things. So this data acquisition part is even more important, and thus, I think for me at least, much more interesting. And yeah, I'm an embedded engineer naturally, so that's where for me the interesting part comes from. But where these two worlds collide, I think that's really where some magic can happen. So yeah, just it was really fun actually creating the slide deck for this talk. I was scrolling through all the photos that I made and that a bunch of the other people in DSA made, and putting it together. And it feels a little bit that everyone is here can join me on this journey a little bit. So this is a photo from DSA in 2017, and yeah, it literally started with I brought a box of hardware, a bunch of Nucleo boards and some sensors, and we figured, okay, let's go and try and do something. And during the first day, it was the day of the first workshop. I think we had a workshop of about 2 or 3 hours. Virtually everyone actually managed to make a device that did something and collected some data and got some experience on kind of how hard it was. But the not much more interesting, but the really cool part of that was that on the last day of the conference, we could actually take all the stuff that we built and that we thought about and actually try and see what we can actually do on real devices and in real use cases. So we took it to the field. So in 2017, we built 2 systems. Well, built is a big word. We hacked together 2 systems. I'll talk a little bit more in detail about the cow use case. This talk is called Chasing Cows for a reason. But the second one was that one of the big issues, and it's something that I never realized, and that is, I think a big part of trying to build something trying to build something for a use case far from home is that you sometimes don't realize kind of what the problems of society are. So we went to a chicken farm, if you can say it like that, but basically we're raising chicks there. And one of the issues is that because the way that they heat the premises, there's places in the area where the chicks live that are much hotter than other places, and that has to do with the airflow and the place where the heaters are, etc. So they all kind of cobble up in the same spot, and then they actually suffocate to death. Now, naturally, that is not a good thing, for the chicks themselves, right? No one likes that, but it's kind of a major disaster for the farmer, because you spend actually money raising these chicks and then they die, and that means there's no money. So this is kind of the interesting part for me, where I started thinking about, actually a couple of dollars is really expensive for a farmer in this case. So we started looking at that, hacking together basically a system that could generate a heat map from data. So these cardboard boxes that you see, so there's one on the right side of the red ring, and then there's one on the left side of the picture. Those were our gobbled up together sensors, and they literally looked like this. This is a Nucleo board, a bunch of wires with some temperature sensors. There was a little Wi-Fi module, ESP8266, and then a 9-volt battery. And then we put it in a cardboard box, and that was it. But really fun. So we kind of grew in this part as well, right? So we went from literally hacking something up with a bunch of dev boards and just trying to do something to actually a little bit more structured approach. So in 2018, we had a couple of use cases actually. The first one was a system to do soil monitoring and environmental sensing. So we had, some basic soil moisture, temperature sensors, and then we also had one to do PM2.5 measurements for air quality. And the third one was that we actually started building camera traps. And once again, these are use cases we try to deploy this in the conservatory. And the one thing that we actually realized, so we figured we were going to do LPWAN connectivity. So we had some base stations, and we figured we're just going to put a base station up. And I know here in Amsterdam, which is a supposedly pretty harsh RF environment, I can easily do like a kilometer of range. So we figured that's going to be fine in the conservatory. What we realized, though, very quickly is because there's so many trees, they block a whole bunch of this RF. And so we barely had any connectivity. And that's something that comes back basically every year. that there's either problems with power or there's probably problems with connectivity. So we've actually learned during this whole part that having an offline mode of your device, whether that's in data collection or in inference, that's where tinyML kicks back in, is actually really important to get conclusions. Bias in your models is also really important. So we trained we wanted to spot animals in a conservatory and built a camera trap. So we trained this on a set of African animals that we found. We deployed it, and all of a sudden, the next day, when we actually fetched the camera traps and read the SD cards to see what the conclusions were, the model actually said that it has seen a giraffe, which is weird. There were no giraffes in the conservatory. But here comes bias into play. There was a llama, and the llama was not in our African data set. And so our neural network does whatever a neural network does, and I have no idea what this thing is that I'm looking at. And it actually defaulted to classifying a giraffe rather than the llama. So kind of fun. We professionalized a little bit. So here was our setup the next year. So we actually put together, well, not a nice box, but we put together a box, relatively waterproof. We had a couple of sensors that we connected much easier with like a little plug-in board. But once again, going into the field. 2019, we upped our game once again. This time we went to a greenhouse. And there we wanted to collect some data, so soil moisture, temperature, humidity, barometric pressure, light, and then we had additional sensors that we could deploy otherwise for air quality and for wind. So this time we actually upped it a notch a little bit. So we built a custom board. You see the DSA logo in the bottom right corner. This board was actually put together by Chris Stiles. He's the same designer of the microbit. I think lots of people here on this call have seen that. So Chris was a colleague of mine at ARM, and he put together this board. Really cool, kind of a base board with a radio, a MCU, so a processor, a bunch of sensors already on the board, but then with like a couple of like cool extensions that you can plug stuff in. So we brought actually an anemometer, like a wind meter, PM25, sensors, soil moisture extensions, etc., that you could easily plug in. And we had a bunch of cases actually that made them waterproof, and it was really cool. Now here comes a little bit of a story myself, right? So the day that we wanted to deploy all of these in the greenhouse, I got incredibly sick. So I got height sickness actually. So Addis Ababa is 2 kilometers or something above sea level. I live in Amsterdam, probably at -8 meters of sea level. Got incredibly sick, so we were not able to do the full deployment, unfortunately. But we left a whole bunch of these boards actually alone. So I hope they got a good home as part of the DSA community. We did a firmware around this to make sure that we actually low power data connection, etc. So that a little bit of the stuff that we did. But all of these and this comes back to the very first point that I made. All of these, the goal here is always like, how can we actually make this data collection part so easy that someone can come in, look at a problem that they actually have, rather than something that someone has gobbled up for them, do something incredibly hyper-local, right? Do data collection on a conservatory, next to the university as we did to take goods, or go to a dairy farm and go talk to the farmer and discuss the problems that they have. And let's see what we can build, with that and from that. And that was kind of the thing that we tried to do. Like, we can't, as I think this is it's a very Western European way to say it, right? But as a person living in the Netherlands, or, someone in the committee living in the United States, has not really an idea of the real problems that society faces in East Africa, right? These problems that you have, or problems or opportunities that you have there, are local, and thus the solutions need to be local too. The only thing that we can do, hopefully, is give tools to people in the community, and then they can take it and actually run with it and build something really, really cool. And so far, what I've seen in the community that has sprung out of DSA, that really has happened. It's truly amazing, the stuff that comes from that. I'll have a couple of examples in a little bit. So that's interesting. I think the economics are much different, which also makes it interesting. Back when I was in Telenor, Telenor is a large Norwegian telco. I worked there from 2013 to 2015. And we were thinking about kind of an IoT deployment in Myanmar. And one of these like typical IoT examples is parked cars, and knowing when there's parking spaces free. And there's lots of like car congestion traffic in the capital of Myanmar. And so we proposed this, and they actually said, well, no, this is never going to work because we can just pay this guy $1 per day to just count the cars. So it's much cheaper than rolling out this whole IoT network and all of these sensors. Same the other way around, right? The life of a cow is worth much more for an individual farmer in Tanzania than it is for a farmer in the Netherlands, right? And thus certain solutions, for example, health monitoring of these cows in a kind of low-cost way, make much more sense in that scenario because it directly depends on the livelihood of the farmer. But the really kind of most cool thing or why I think this is really cool is because it's just two worlds that collide, right? It's the world of embedded software that I'm in, that I do on a day-to-day basis, and the world of machine learning that actually tries to make sense of the signals that come there. And this is also why I think the tinyML community is insanely cool, and I don't really understand why it took so long before that popped up, right? I never even thought, I never thought of this combination until I actually went to DSA. And I think not the reason, but I think a big part of the reason of why I'm in the field right now, doing this stuff with Edge Impulse, is because of the experience that we had at DSA. So yeah, let's look at some interesting things that I've seen, some DSA related, but kind of all stuff that is being deployed in Africa today, and the way that tinyML makes a difference in these use cases. So the first one is a project by Thijs and Tim from Q42, Hack the Poacher. So Q42 is an agency here in the Netherlands, and they've kind of this Tech for Good program where they work on stuff that is beneficial for society. And one of the things they're doing currently is deploying camera traps in Africa to detect poachers and animals. And man, this is such an amazingly cool idea, right? They do it a little bit wider than just camera traps. So they have a second part of their system, which actually does detecting of cell phones used by poachers. And it uses to actually give rangers to actually identify whenever a poacher is somewhere close or when there's human-elephant conflict. And they can dispatch rangers through that. I think this is such an amazingly cool idea, right? It's almost impossible. Okay, so there's a couple of things why this is cool. One, just the technology is insanely cool. Like, how cool is it that we can actually have a battery-powered camera with an ML algorithm that can actually detect, wild game, and that can detect poachers or humans basically in the vicinity of stuff. How cool is that? And more importantly, how cool is it that we can run all of that on the device itself, right? This is killer. If you're deploying something in the savannah, there's probably not going to be great 5G coverage. And even if it's there and you want to stream a video stream over it, you're going to run out of battery in a couple of hours. What they can do now, and what Q42 is doing in their first iteration, and we're working with them on a second iteration of this camera product, is that they deploy this battery powered with a solar panel, communication back over either LoRa or 4G, like cellular, or over satellite backhaul, and then you send back whenever there's something around. And this is really cool because you do all of these calculations locally on the device, only when there's movement. This is actually feasible from a power perspective. Like it's a complete standalone product that basically doesn't need anything to happen anymore. A second thing that they actually do is to detect, I said a little bit, but they detect people in the vicinity by scanning the wireless spectrum and looking at kind of LTE signals. How cool is that? And the way to do is it's ML, right? You have a spectrogram, you train it on, okay, this is what chirps from a GSM modem actually looks like. Okay, cool, let's run it. And whenever you see humans and large animals in the same area, dispatch rangers. As easy as it is. The second is actually a project that we did some work on back in 2017, and I'm super happy that Shira and his team at Descartes University continued it, is basically a Fitbit for cows. So one of the things that, well, I think about a lot of different stuff, but I never thought about this. A sperm sample from a cow, I don't know what a male cow is called in English, but a sperm sample from a male cow is between $2 and $4. Okay, so it actually means that for the farmer, they actually only want to inseminate the cow when they actually know that the cow is in heat, because otherwise the sperm sample goes to waste. So how do you know when a cow is in heat? So Shira's team actually had this thesis that they're working on that said, well, you can actually detect when a cow is in heat because they start acting differently. And then the second thing, like if you can detect that, then maybe you can detect when a cow is sick, right? Because its behavioral pattern changes. So yeah, what they're building as just such an amazing cool use case is essentially a Fitbit for cows. So it has an accelerometer. It has a collar around the neck. A couple slides back, there's actually a photo of it. Has a collar around the neck. And they can train that on an activity detection model, very similar to what you would do on a Fitbit or an Oura Ring or your Apple Watch, right? It knows when you're running or when you're taking a brisk walk outside. Now we can actually train that on now we knew that this cow was in heat at that point. We knew that the cow was sick, and we can actually start predicting that a couple of days beforehand and spot those anomalies earlier and actually alert the farmer. So the very first way that we built this system back in 2017 was we didn't really think about this data collection part yet. So I figured, okay, a cow is just walking around a little bit. I mean, cows are not that active. So what we did was we took these dev boards that we had, we put them together, we put the accelerometer on it, we had a little Wi-Fi chip, and I was just streaming that data to my laptop. And I was just standing there in the fields together with all the students. You see a couple of them walking to the dairy farm here. But the farmer actually had these cows standing in an enclosed surface for about an hour, basically, when he was explaining stuff about the problems that he had and etc. So all of a sudden, we finally put the collar on. The cow started running, and we had people actually writing down what the cow was doing at that point, because then we could actually train the model on that. We could cross-reference that. So cow was walking, cow was running now. And this cow was running like crazy, going out of my Wi-Fi signal really, really quickly. So if you were there on that day in Tanzania, you would have seen about 40 students standing in the fields in a dairy farm, and one incredibly white guy running after cows with his laptop in his hand. This is a real story, and this is how we built kind of our first data set from that. In a very similar approach, and this is something that we are doing together with, well, we and Hackster and a whole bunch of other companies, Microsoft, together with smart parks, building a collar for elephants through elephant tracking. So human-elephant conflict is a much bigger and bigger problem, not just in Africa, but also in Asia. So accurately tracking where an elephant is, not just for poacher detection, but also to make sure that they don't come too close to human enclaves, becomes more and more important. So what they're building now is the world's smartest elephant collar with Elephant Edge. You can head to smartparks.org to actually go there. So there was both a contest where people in the community actually did something really, really cool, and now kind of with all the funding that was received in the project, Smart Parks is actually making this elephant collar. It is insanely big. Like I'm not exaggerating. It's literally this size. Hang around an elephant's neck. So we're even doing Fitbits for elephants now. And then another one. So in conservation again, naturally, one of the cases you could say, well, we do like monitoring crops, etc. But I think it's such a basic use case that everyone's heard already. So a much more interesting or a different one is animal tracking in the widest sense. So this can be stuff like, oh, I want to know what the animals in my conservatory are, but it could also be that I want to know what kind of birds are in a certain area. And audio is an amazing way of actually identifying that. So I was reading a paper this afternoon about this, and through audio classification, they're able to actually spot a much larger range of birds and much more birds than a human observer can actually do. And how cool is it that you can actually build something like this to identify birds or other animals, but because it's now possible to actually analyze everything that is happening around that sensor right at that same time, thanks to tinyML and everything that's happening in that field. And thus you don't need to actually store this on an SD card, and then someone needs to actually go retrieve it and then label that and say, oh, I heard this bird, I heard this bird, I heard this bird after the fact. But rather you can already collect all of that on the sensor itself and then ship that off to a central location. So this is, if you search for Lacuna Space and Edge Impulse, I forgot to put a link here, or maybe it's on the previous slide. You'll find a project that is actually a waterproof case that is doing exactly this. So it's counting birds, and then once a day, it's relaying that information, the count, back over satellite to a satellite from Lacuna Space. Battery powered, runs months on a battery, constantly sampling. And man, how cool is it that we can do this kind of stuff? This is science fiction things, right? You deploy a device, you just make it sit there. It listens to what's happening. It's counting the animals that it sees, and then it's actually sending it over a satellite. Like this, there's no more 21st century technology combined in here. So really wide. So there's actually a lot more of these things. So I highlighted 3 use cases. We have limited time available today. But if you're interested in kind of seeing what the community in Africa is doing, take a look at the DSA Research Award. So that's at datascienceafrica.org. You'll find it straight away. It has 10 examples of stuff that people have received grants for in applying machine learning to local problems in Africa. So there's a lot more where this came from, but I wanted to highlight kind of these 3 little basic things. And kind of the key of them and kind of why they all benefit from tinyML is, on one end, I think they allow us to understand the world and to monitor the real world without human intervention and without humans actually monitoring. Humans are, well, they get fatigued, they are expensive, and in some situations, it's actually dangerous for a human to be somewhere, right? If there's a poacher near an elephant, you probably don't want to have a human actually monitoring that, but rather having a machine do that, and then whenever there's danger, they actually can send some rangers in. The other thing is that what I found, and it's kind of weird realizing that if you're, doing this from your apartment, that power might actually be an issue when deploying these kind of things. While we're at the greenhouse at DSA 2019 in Addis Ababa, a really, really big city, we actually realized that there was no power at the greenhouse. So we secured a gateway location because we needed to send some data back to central location up a hill. But I don't know, there was something happening with the antenna, and then something actually happening with the gateway, blah, blah. Long story short, we could not get coverage in the greenhouse. So we drove around Addis Ababa for a morning trying to find a generator. And then that's the generator actually that you see there on top. And at the bottom, we actually realized that the generator didn't have the right plugs. So we literally duct taped some plugs together, and that's how we powered the gateway. So not that great if you want to deploy something, in real life, it's really great if the sensor is running standalone. Then, coverage might be a problem as well. Maybe there's 4G or cellular coverage. Maybe there's not. Maybe there's some LPWAN like LoRa or Sigfox available there. Maybe you actually need to relay to satellite. There's always direct effects on kind of the amount of data that you can send. And thus tinyML is so incredibly cool, right? If I can process this all on the device and the device can make those conclusions for me, that is amazing because I don't need to run the radio. That means that I don't need to buy coverage from someone. It also means that I don't need to deplete the battery so quickly because driving a radio is really, really expensive. And thus my solution is becoming much, much more interesting, right? And then if you need to send something like a small signal over time, you just literally send some data over a satellite, for example, with just a couple of bytes. So that's really cool. So yeah, let me kind of close off in the next 7 minutes or something with some challenges that we see and how you can contribute to that, and then we'll head to Q&A. So still, I think, and this is something that we're working on a little bit with Edge Impulse, but we're definitely not there yet. This building a data set is really 90% of the work, right? Once you have good data, it's trivial to create a ML algorithm. And a lot of I don't know if there's a lot of ML engineers on this call, but the typical discussions that I get into with ML engineers is, well, we need to use this algorithm, or no, neural networks are overkill for this thing. We can use some classical ML. Like, who gives a shit, right? Once you have the data, it is trivial to figure out what a good architecture is to classify the thing that you actually want to know, right? But building a data set is a lot of really hard work. Preferably in a situation where you can actually leave this device and capture data for a couple of days or a week or even longer without having any assumptions that you need to make. No assumptions about internet coverage, no assumption about power that's being available, etc. And something that needs to work or can work actually in humid and warm climates as well, right? And even if you have a device that can actually do that, it still requires a lot of planning. This is a photo of deploying the air quality sensors, I think, in the conservatory in 2018. This is people climbing into a tree to deploy a sensor. And the next day they basically have to do it again to get the data back from the sensor or and get it from there. So getting a data quality is really, really hard. And if there's one thing that I could wish for in this, is that I would love to see more devices like the audio moth. So this is a low-cost, basically a microphone and logger. I think it sells for about $50 or something, $60. And man, this is so incredibly amazing. It's a completely standalone device. It runs on a couple of AA batteries, and it is an absolutely awesome data logger to get raw acoustic data from the field. This kind of device, I want to see more of that, right? I want to see a device that can do all kinds of gas sensing or something, PM2.5 sensing directly in the field, and get the data into the hands of researchers as quickly as possible, in a way that the audio moth is doing it. But then on the audio moth, I also want to be able to run my inferencing straight on this thing. So especially it's not a criticism or something to the tinyML community, but I do think it's an opportunity, right? We, including me, right, most of us in the community are software people, right? And we like to solve problems at that point. But I think there's this huge opportunity of building hardware that is capable of actually collecting the data in the field in a good and fast and accurate manner, and getting the data ready for building ML models. And I think that is I think the biggest way that we can help Eastern African communities in a way, but I think this is going to be super applicable in a much wider field as well. So if there's something you want to do, come talk to me and start thinking about this. So we started a little bit of that work now together with Q42. So we're working on a open camera trap that has all of this in there, right? So it will come with two modi, so a data capture and an inference mode. And during data capture, you can either capture to SD card or internal flash whenever there's something interesting happening. You can get the data from the device really, really quickly, either remote if you have a good internet connection, or just from the SD cards. Then we can build this whole software ecosystem that everyone is already building, right? So you can train your model and verify the model, blah, blah, blah. That's great. But then I want to be able to deploy that model back to the device really easily too, either by just plugging in a new SD card or sending a remote switch. And then I want this device to be properly designed, like a real device, like something you could just buy in a store. So these Bushnell sensors, these are kind of state of the art, and that's the one that people buy for this kind of work. They're nothing like this, right? They literally have a little IR sensor to basically sense motion. They just have a picture, and that's it. And that's mostly because they're used, and they can send some data over cellular if that's desired. But I want something really made for ML and for doing camera traps right in the fields, rather than something that's actually made for hunting, which all these Bushnell things are. So let's build something like that. The second challenge, kind of a fun one, is that getting hardware into Africa is really hard. I don't know. I don't understand why this has to be. But, well, if here, for example, a resistor breaks or something, or, I need a new IC, I go to DigiKey, I type the part number in, next day I have it. The coordination amount that we needed to get through to get all of this hardware into, for the workshops actually, in the right location, man, that has been traumatizing. During my first trip to Tanzania, my box was being held, I think in Kenya, when I was doing a transfer, and they didn't want to give my box back. They wanted to know what was in there. They didn't want to give it back, blah, blah, blah. A whole back and forth. And I was incredibly worried because the next day I had to give a workshop to students. So we drove over, and this is the box you saw in the very first picture I held above my head. We drove over to the airport in Arusha. I buffed my way through security that actually checked everyone that's going out, and customs. I walked into the arrival hall. There was no one there because, well, there's no planes arriving. I saw my box, the one that they didn't want to give me back. And I just took it and I walked out. This is the kind of stuff you need to go through. Similar, actually, and so kind of the lesson that I want to give here is, let's make it as easy as possible, and let's actually make it a product, right? Because then it's no longer boxes full of devices or boxes full of like random components that you all need to assemble. Let's just work on something, and preferably let's do it locally. Let's set up a distributor line and actually build something there. So if people are interested in that, come have a chat with me. I'd be happy to kind of start thinking and think about funding for that kind of stuff as well. So yeah, to conclude, kind of where Edge Impulse pops in and kind of my journey towards this. So kind of had two goals when we founded Edge Impulse, and that is, if you're an embedded engineer, you know everything about acquiring this data, right? You're me, basically, in 2017. You know everything about acquiring data, you know everything about deploying models to devices and how that kind of whole flow needs to go. So we built Edge Impulse, kind of place where embedded engineers can use ML to understand the world. But a secondary goal that, we're not there yet, but I think we're going to go there, especially with the new stuff that we're doing around camera traps and the hardware ecosystem we're building, is that I hope that we can actually let ML engineers use all the tooling around it to actually capture data from the real world and then finally deploy that back to embedded devices. And I hope that we can make like a small dent in that and do a little bit of influence. So Edge Impulse is here to help. If you have an awesome project in Africa, you want to get some help, either design help or just want to have a chat with me about stuff that we could do, reach out. I'm always happy to have a chat there. And yeah, if you want to get involved, if you're outside of the community, talk to the community first, right? They have amazing insights in what the real problems are in their local communities, and that's something that we can't solve. Right, we can help, and we can make the tools available. But let's talk and see what we can do there. And yeah, if you got inspired by all of that, or after you've talked to some people in the community, or you've talked to Clinton and some of the amazing work that he's doing, and you think, wait, this is super cool, I want to do more of that and get even deeper involved, sponsored or even visit, right? We're going to be back I hope they're going to be back in 2022. Come visit Data Science Africa and join me and all the amazing lecturers and students and actually building stuff in the field and making real impact. So with that, thank you so much. And I'll give it back to Clinton for Q&A.
Okay, thank you, Jan. So regarding question, we don't have much questions currently, but for members who have attended, kindly, if you have your question, kindly post it on the Q&A window just at the bottom of your screen. So some questions were posted on the chat, and one of it was like about the battery cost comparison between transmitting data and performing ML at the edge.
Yeah, it's so driving a radio is really expensive, right? So on cellular, especially if you go from deep sleep, you need to make connection to the cell tower, do this kind of handshake, and then send data over. And you're basically bursting for 30 seconds or something to set that connection up. And in that, you're probably going through about 100 milliamp of power for the 30 seconds. So you're burning through your battery really, really quickly. However, with ML, that's also possible, right? If you're constantly listening to the audio channel and constantly doing inferencing, that is going to deplete your battery very quickly too. So then you don't win a lot. But we don't need to do that. So we can take a look at camera traps, for example, where you typically have a motion sensor, and only when the motion sensor triggers, that's relatively low power, then we actually spin up the main MCU, snap a photo, classify what is happening, and then act on it. Same with audio, right? You can say, oh, wait, you have some of these MEMS microphones that can actually detect audio above a certain level. When that happens, that's the moment that I wake up and actually do stuff. Or when I have an audio, when I'm counting birds, I don't need to do it constantly. I just, every 10 seconds or something, I wake up for a second, listen. So I still need to do a bit of duty cycling, but driving a radio is so expensive. Even LP WAN radios like Aurora, that you can do a lot in that. So almost always it's going to be cheaper to do the processing on device. But as we say in Dutch, measuring is knowing.
Thank you, Jan, for that. Another question. This is not a question, rather is a request. Could you kindly give the link for the Fitbit cow project?
Yeah, so that's actually.
So as Jan is looking for that, if you have any question, kindly post it.
So this is the link. At the bottom of the slide here, you see Shira's research.
Okay, great. I've seen another question. Hi, Jan, I need your help in getting audio mode here in Addis Ababa. Yeah, it's some kind of a request.
Okay. Yeah, just reach out to me at jan@edgeimpulse.com, and I'm happy to think about ways that we can support you.
Great. It seems that we don't have much question. Any other question from the Q&A window? So kindly, if you have any question, we are going to continue the engagements on the tinyML forums. If you have any questions, go kindly post it there. So we have another question.
Yeah, I'll be.
So what is the next?
I fucking lost my audio.
Okay, another question. What is the next step for tinyML? What are the current topics of research in this field? That's a question from somebody.
I lost my audio, Clinton.
Oh,
I don't know if you guys can still hear me, but
no, we can't hear you.
Can you say something?
Hello, Jan, can you hear us?
Okay, I think it's fine now. Sorry.
Okay, great. So we have some more questions for you. So another question that was asked: as you scale such projects, how are you handling issues around data sovereignty?
So what do they mean with data sovereignty here? I don't know. Okay, I don't know that, but drop me an email or post it on tinyML org forums page, and I'll take a look at it after the talk.
Okay, great. So another request: how can I reach Jan? Maybe Jan, you can just post your email on the chat.
Yeah.
Great. So another question: what is the next step in tinyML? What are the current topics of research in this field?
Oh man, do you have a minute? So I think we start to see that we can do much more on kind of similar type of hardware, right? And that is driven by the community on one end seeing there's a lot of okay. Where we're going with all of this is that I think that stuff that you can do today on, let's say, a Jetson Nano, like doing object detection in video, that is coming rapidly down. And that's other, like real-time audio inferencing used to be like on a Cortex, first on a Cortex A device, now it's already in a Cortex M4. That's going to go even down even more. And that brings some really amazing things, right? All of a sudden, device can get more capable over time. And we all know that, if you're building a new device, and you want to do tape out and actually want to get into, getting it into a store, it's going to take whatever, year and a half basically of design time. If all of a sudden your brownfield devices can become smarter because our algorithms get smaller at every point, that is really cool, because then we can start actually, evolving this software over time. Whether embedded developers are ready for that, I don't know yet. But the big overarching goal that I hope that we're going to, and what I feel that tinyML is going to kind of result in, is that machine learning is going to be a tool in the toolbox of every embedded developer 5 to 10 years from now. And that, when you're facing with a problem, you think, hey, actually have some sensor data, I know there's a correlation, but I don't know how to fix it. You'll look at machine learning. But I think that machine learning is going to be a tool in the toolbox of every embedded developer, like signal processing is today. So I think that's, if we're looking at really kind of what the amazing developments are going to be, then that's definitely a place.
So another question, I'm not sure, but I think Edge Impulse uses TensorFlow. Why? Are you considering using PyTorch?
Why? So TensorFlow is much more than a training library, right? It's an ecosystem that is spun up around it. And that is for us really, really interesting. So for us, TensorFlow is not just a place where we train some neural networks. We use some other stuff as well, by the way, to do non-neural networks, but it's the cool part where, we want to deploy something in Cortex-A. Okay, there's XNNPAC, right? That has really fast code with SIMD instructions on Cortex-A. We want to do something in Cortex-M or ARC DSPs. There's actually TensorFlow Lite for microcontrollers. There's something new, interesting, like quantization of our training. It's always, in TensorFlow first, and that has been really cool. And it helps that our lead ML engineer, Dan Sitaniake, used to be in the TensorFlow team, so that's biased a little bit, but that's kind of the reason. But we use lots of other stuff, right? So all our DSP code is handwritten. For our classical ML algorithms, we use whatever is the best thing, if that's in scikit or whatever.
Great. Since we have some few minutes left, so maybe we are just going to tackle some other questions that have been posted. So another question, can you talk a little bit more about commercialization?
For the stuff that we do, or for the stuff that people do in the community? So let me take it on from my maker standpoint, right? I think commercialization of this, I think there's so much value to be captured here, right? That I think for people in the community that are thinking about that, there's so much. So I've already phrased it, but there's so much value to be captured by this, because we can actually, capture signals from the real world and analyze them in real time and not have the human in the loop. That this can have an amazing effect on the economy, and once you have that, it's really easy to capitalize on that, right? If you can save a dairy farmer, or actually tell a dairy farmer that a cow is getting sick a couple days in advance, and thus cow doesn't die, or there's no issue with the dairy production, there is so much value in that to be created that I think it's going to be relatively easy to capture that. If you have a use case where you think where you might have problems or something with capitalization on that, Edge Impulse is starting a market development fund. So it's going to be a $1.2 million fund, where we're going to writing up to $100,000 checks for really interesting stuff on the boundary of machine learning and devices. So if you have an amazing thing or amazing product that you think you want to work on, but you have some issues with raising funds or with the commercialization of this thing or with the feasibility of that, come talk to us. We'll have MDF funds starting in 2022, where we can fund these types of projects from.
Great, thanks for that. So it seems there's no other question. We're going to stop it from there. So kindly take the 5-question poll and continue the conversation at the tinyML forum. If you have any question, they're going to be answered there. So as we finish, we are just going to give another round of appreciation to our tinyML Talk sponsors and strategic partners. So so we'll start with ARM, the software and hardware foundation for tinyML. Next.
Yeah,
Deep Light, we use AI to make other AI faster, smaller, and more power efficient. Edge Impulse, tinyML for all developers. Next. Next one, enabling the next generation of sensors and hearable products to process rich data with energy efficiency. We have HOTG, distributed infrastructure for tinyML apps. Latent AI, adaptive AI for the intelligent edge. SIM integrated, enabling edge intelligence. Quickzo AutoML, automated machine learning platform that builds tinyML solution for edge using sensor data. Reality AI, add advanced sensing to your product with Edge AI stroke tinyML. SenseML, build smarter IoT sensor devices from data. ScienceSense builds sensing and inference hardware for ultra-low power, embedded mobile and edge devices. We design system for reality time analysis, always on smart sensing for audio, vision, IMU, and biosignals and more. We have sentient neural decision processes. Then don't forget about the next tinyML talk, which will be happening on Tuesday, 19th October. It will be about tinyML for conservation panel. And if you have a talk that you want to submit, kindly reach out to tinyML, kindly reach out to talks@tinyml.org for more information. Yeah, and we are done for today. Meet you next time.
Woohoo! Thanks, Clinton. Thanks, everyone.
Thanks, Jan.